Here we have a geometry scenario where we have a transversal being cut through a pair of parallel lines. So a parallel line is being cut by a transversal. And the reason we know they're parallel is because of this icon here, like those arrows indicate that they are parallel. So we know the two lines are parallel, and it's being cut by this transversal here. This transversal is cutting right through. There are a lot of relationships that are made when we have parallel lines being cut by a transversal. And in this scenario, we want to solve for x, where we have this part and this part. So we have to figure out, well, what relationship do we have between these two angles that will allow us to then solve for the unknown variable. So when I have two parallel lines being cut by a transversal, I kind of have two sections. I have the interior, which is here. So the interior is that inside portion between the parallel lines. And then we have relationships that develop inside of the interior. And then we also have the exterior of the parallel lines. So the exterior would be this portion. And then from there, we have some relationships that are developed between the exterior and the interior. And then there's even more, like, for example, if this was 15, let's say 150, these would be vertical lines. Same thing here. If this was 150, these would be vertical angles, where we know that those are congruent if they're vertical angles. And then we have supplementary relationships that we can make. So if this angle was like 70 degrees, these two angles would be supplementary, the 70 and the 3x minus 20. There's just a lot of different relationships that can be made that we can piece together. But for right now, let's just focus on the fact that we have two parallel lines. So these two angles here that we're looking at are on the exterior of the parallel lines. And then when we have this transversal, these two angles that we're looking at are on the other side of that transversal. And what I mean by other side is, if I were to just call this, let's say 70 and this 2x plus 25, that would be on the same side of the transversal, where 3x minus 20 and the 2x plus 25, those are on the opposite sides. So the relationship that we have between these two angles, since they're on different sides of the transversal and they're on the exterior of the parallel lines, we have alternate exterior angles. And when we have alternate exterior angles, those angles are then congruent. I'm going to call this A and call this B. So A and B are alternate exterior angles. So I could say angle A is equal to angle B because they're alternate exterior angles. So I'm just going to take the angle A that I called 3x, and that's 3x minus 20, equal to the angle B, which is 2x plus 25. And then now I'm solving an equation. I have variables on both sides, and I just have to solve. So I'm going to subtract 2x from both sides. I get x minus 20 equals 25. And then I'm going to add 20. I get x equals 45. The problem's only asking for the actual value of x. They're saying, what is the value of x? So I'm just going to go ahead and identify x equals 45. But let's just pretend that they were asking for, well, what is angle A? Like, what does angle A actually equal? I would then say, okay, well, angle A is going to be 3 times 45 minus 20. So I replace the x value with 45, whatever I solve for x. So in this problem now, I have 3 times 45 minus 20 is 115. So angle A is equal to 115. And you could tell that, you know what, maybe that is, I was going to say that might not be drawn to scale very well, but actually that does look like kind of a convincing 115. And then just building on this list a little bit more, if this is 115, I'm going to call this angle C over here. I could figure this side out because we have a straight angle here. And when we have a straight angle, that means that these two angles are supplementary. So I could say angle A plus angle C is equal to 180 because that's a straight angle. So I could just say angle C plus angle A I just solved for, that's 115 equal to 180. And I know the question is not asking this at all, but just expanding on our knowledge here of two lines being cut by a transversal, two parallel lines being cut by a transversal. So 180 minus 115 is 65. So angle C would equal 65 then. And if you really wanted to go crazy, if you really wanted to just fill out this whole thing, whenever I teach this lesson in my geometry classes, whenever I start talking about parallel lines being cut by transversal, I'll kind of we'll get to a point where we'll talk about all the different relationships, and then I'll give them this figure. I'll give my students this figure, and I'll just say, like, this angle right here is 75. Do the rest. And so then they would have to piece together as a supplementary, and then so like from here, that's not equal to 75. But I'm just saying that that's the kind of problem that I would give my students, is I would just give them a single angle, and then you'd have to piece together everything. And these are kind of fun, because if I know angle A is 15, I'm going to call this angle D. This angle is also 115 because of vertical angles. And then if angle C is 65, that means this is also 65. And then if we have, this is 65, these are alternate interior angles. So those are 65, 115, alternate interior or supplementary. And then these are vertical. Angle B is 115, and angle B is also equal to angle A because of alternate exterior, as we talked about. 65, 65. You could piece together this whole thing. It's actually pretty fun. I like doing those kinds of exercises. But it's way more than this question asked. All I wanted was X. Just got a little carried away.